Hello, Philly Jug, and whoever is out there. Hope you're all doing well and staying healthy. You're joining us for the What is CQRS plus Event Sourcing and Why Should Java Developers Care presentation from Reza. Reza Rahman is a Principal Program Manager for Java on Azure at Microsoft. And he's been a member of our committee for a long time at this point and a very active member of our local Java community. The host and sponsor of this event is Jakarta EE, open source cloud native Java, and they are all about enabling community-driven collaboration and open innovation for the cloud. If you want to know more about them, then we shall send some links for that later on. During today's presentation, we will be running a raffle. Jeannie, would you like to talk about that?
Yes. So every month, JetBrains gives us two licenses to raffle off to someone who's at this meeting. So what I'm going to do is I'm going to send out a link to a Google Sheets spreadsheet. You put your name there, and towards the end of the meeting, I'll shuffle them, and whoever's at the top, the top two will get a license. And I'll send you the license by email. So sure. I'll contact you for your email and then send you the license there.
Okay. We will share that link. We'll share that link in the comments. And when we're about to close it off, we will also make that note in the comments. We will be taking your questions as we go through the presentation. If you could ask them through the Ask a Question link on the page, that would be very helpful, because then when we answer them, we can timestamp them so other people can find them in the future. With that, I think that covers all our introductions. Reza, we hand it over to you.
All right, fantastic. So first of all, thanks for folks for showing up. I think this is an important topic. I have to tell you, I've used these design patterns occasionally throughout my career. It's not very, very prevalent. But it's one of those things that you really need it when you need it, right? So it's one of those things that you should have in your tool belt and have a proper understanding of what it is. And honestly speaking, that doesn't really exist very much either. I'm happy to present on this topic. The basic objective here is explain what these concepts are, what these design patterns are, and why you should use them. I used to work for the folks that produce Axon, which is the only known Java framework that basically targets this particular domain. As a tip of the hat to those folks, I am using their slide template. Feel free to check them out, of course. All right. So yeah, basically we want to start with the question why, right? So why do you want to use these things, and what is the value proposition? Why do you want to use CQRS? Why do you want to use open sourcing? And why do you want to use Axon? In fact, in general, I'd say these are good questions for using just about anything in our industry these days. So let's start with why CQRS. That is a logical place to start our conversation and begin to understand what are we dealing with here. So CQRS stands for Command Query Responsibility Segregation, and it's a big mouthful. But honestly, it's not really as scary and obscure as it sounds. Fundamentally, the concept is not that difficult, right? So it is geared towards things in the real life, and it is a particular way of solving very common problems, CQRS in particular. So let's talk about what CQRS is. So I'll start with sort of a joke, right? So on screen here, obviously I don't expect you to read this the SQL statement on screen, but the SQL statement on the screen, if you were to look at it, there's about 22 joins and 6 subqueries in it. And this is not really that unusual, whether you're handwriting the SQL statements or whether it's getting generated by something like Hibernate or JPA. This is the sad state of affairs is that this is a very, very common situation, this level of complexity in queries. And it's important to understand why. Why is that? So we should at least begin to understand, if not attempt to solve this problem, of why this is so normal, right? And why this doesn't raise any eyebrows when you're dealing with day-to-day development. So the fundamental reason actually is this. Fundamentally, what happens is that we, in order to understand our domain and to model our domain in a maintainable fashion, we need to model the domain in ways that make semantic sense. And in general, what that means is fully normalized tables. And it also so happens that the entire RDMS concept, in fact, database concepts in general, are geared towards this concept of normalizing things and creating a domain model, both in terms of for our conceptual understanding and also because that is, in general, the most optimized way of storing and retrieving data, okay, in general terms. The monkey wrench that's gets thrown in is that it's one thing to store and conceptualize the data in one way. It's another to represent that data in a useful way in an application. And those things often do not match, right? So in order for those things to make those things match, what we tend to do is write these very complex queries and sort of manipulate the data and stretch it and bend it in ways that would make sense in our application. And in general, that represents the read model of our application. So there's this conceptual problem really that exists between having a write model or a canonical model of our application and how this application is visualized, or the read model. So this is really what CQRS says is a solution to this problem, is because we have this natural segregation of how an application, how data is used in an application, or how data flows through an application. Why not simply segment those things and treat them as different problems? Okay, so that is basically what the diagram here is showing you. So in a particular application, you'll have the write model that is fully normalized and will look like very much the real world domain, whereas you'll have the read model that is also not just materialized in terms of ad hoc queries, but actually is realized in physical form inside the database. So think about specialized tables just for the purposes of representing this data. So that is what the read model is. So it's literally tables that are denormalized for the specific purposes of perhaps visualizing a particular screen on your table or a particular report that you need to generate. So instead of trying to generate this data and working very hard to write very complex queries to generate this data on the fly, what CQRS is telling you is, hey, why don't you actually store the data in that way, in a separate model from your read model? And typically what will happen is there will be sort of a table per view model, right? Is what CQRS at the end of the day really is recommending you do, is that if when you have a UI, have a table that basically has a one-to-one mapping between this table. So when you do that, you are basically going against a big dogma of relational databases, and that is normalization. You're automatically introducing redundancy, data redundancy. So the other question the CQRS needs to solve is, okay, so how do you then solve that problem of keeping these two data sets synchronized? And the answer is materialization. And materialization could be any number of different things. We'll talk about that in a second. But one answer to materialization is the other part of that we'll talk about, and that is event sourcing, right? But that is a design pattern on its own domain. It tends to be used very heavily with CQRS because it makes the materialization portion a lot simpler. But a simple way of materialization could simply be database triggers, right? So you write some database triggers on the right part of your domain model that represents your idealized model for your application. And then as you're inserting data, you will fire off a trigger that will repopulate and make sure the read model databases are up to date. And that's a very primitive way of implementing the CQRS model. And at the end of the day, what happens is you have your UI. Your UI queries your reads will always be issued against the read model. So you'll visualize something, but the actual commands to actually change the data, that will go into the write model, and then the write model, as it receives those commands and makes updates to the data model, will materialize the read model in turn. Okay, so there's this interesting little data flow that is going on in your application if you were to use the CQRS model. So again, the big benefits of doing this is faster and simpler queries, right? So because you're not needing to write those complex queries offhand and having to execute them on the fly, your queries become much simpler. It's literally you select star from whatever the view table is that represents a particular UI screen, right? It's as simple as that. And all of the complex things actually happen behind the scenes in designing these tables, right? So you design those read model queries and materialize them in a way that is a bit more complex than what you would normally do. But the trade-off is you're getting faster and simpler queries in the end. The other important aspect of this is when you break up the read model and write model in this way, you can actually optimize your persistence technologies as well, right? So one very common design pattern with CQRS, for example, is using a relational model for the write portion. Again, that makes sense. RDMSs are optimized to model your domain and apply normalization and data consistency and asset properties in general. Whereas in the read model, all you're doing is retrieving some data and visualizing it in some way. There's no particular need for that particular portion of the model to be in a relational database table. You could dump that data out, for example, in cheaper storage in terms of NoSQL, right? So or you're offloading a bunch of the read operations, almost more than half of your application, to some cheaper database storage mechanism that doesn't care about ACID and doesn't care about all these things. You can optimize your data storage that way. You can potentially throw more hardware at the read side than the write side. So in applications that require a lot of scalability, you almost have to do this, right? So this is a way of basically decoupling your database and throwing more hardware at your database that otherwise wouldn't be possible. So that's another benefit of using the CQRS model. And enabling event sourcing. So you can do event sourcing on its own. In all reality, when you do event sourcing, we'll talk about this in a second, but visualizing the current state of your data is actually pretty expensive, right, in event sourcing. So really, in practical terms, if you are to use event sourcing, you almost have to use the CQRS pattern with it as well. Okay, so I've been talking for a little bit. I'm going to stop for a little while and actually take some questions and see what questions people have so far, right, about CQRS before we sort of dive into and understand what event sourcing is.
There are currently no questions in the ask a question thing, and I haven't seen anything pop up in the comments either. So,
okay, how about you, Paul? I know you had an interest in this topic. Do you have anything? Do you have any questions so far?
My interest is in the event sourcing component of it.
Okay, all right, fair enough.
Oh, so a question just popped in.
Yeah.
Are there any domains this works particularly well or badly for?
That's absolutely. Yes, we'll talk about that towards the end of the presentation. There are most certainly patterns of where these event sourcing and CQRS is applicable in terms of industries and particular domains, and some places where it really isn't a good fit. If you're using that in that domain, I'd be a little bit surprised, right? But there's certainly certain domains where this CQRS and event sourcing is much more prevalent than others.
Brilliant.
Okay, so
thank you for that question, Eric. Let's mark it and move on.
All right. Fair enough. So, so let's talk about. But if I don't answer that question, feel free to ask me again at the end of the presentation. Okay. So enabling event sourcing. So let's talk about event sourcing now, right? What is event sourcing? So this is again a little bit of a scary thing, but actually it's fairly simple, right? So if you let's think about relational databases for a second. So let's talk about a table. So when you're talking about a table, you're talking about the state of an entity. In fact, a particular row in a database table really represents a record, more or less, right? So, but the issue is that entry in the database actually is representing much more than just a record. It's representing the current state of that record, right? So the current value, whatever the current value is. Let's think about, for example, an address table, right? So if you're looking at the address table and there's an entry there for your home address, well, what that is really telling you is this is your current address, more or less, right? It's not actually telling you what your past addresses were, right? Or how you have changed that address. For example, let's say you changed your township changed postal codes. Happens every now and then, right? Or so they renumbered your street numbers, right? All of that history is actually not represented in that record. So that record is really telling you the current state of what happened to that bit of data. Event sourcing can tell you that same information and actually will store that same information more or less, but it actually stores much more than that. So in event sourcing, what you are actually storing is the history of that record, right? So not necessarily the current state, but what happened with this record over a period of time, right? So you'll start with one state, for that record, and you will alter that state over a period of time. Another good example probably is if you log on onto your online banking system, you'll see your current balance is this, right? That is current state. That is, it's telling you what the current state of things are. But when you look at your actual statements, right? This was debited, this was credited, all of these things, that actually is more or less what event sourcing is about, right? So it is actually storing what happened to this bit of data over a period of time. It's storing the events that occurred to that bit of data. And as a result, what you can do is you can aggregate those events and come to what your current state is, right? As opposed to simply having your current state ready. In a way, the current state is actually a visualization of all of the aggregates events, all of the things that happen to that bit of data. So that is really what event sourcing is about, right? So it's about sourcing your events. So you know what the exact things that happened in your system for a given bit of data. All right. So now let's tie together event sourcing and CQRS, right? So typically this is how things work, right? So event stores or event sourcing is never right for the read model. Okay? So in the read model, you're really interested in current state for the most part, right? Unless you're writing an online banking system and you do want basically frequent access to all of your history. For the most part, you actually won't need your entire history every time, right? So what you want is a read model. In the write model is really where you are going to write your domain in terms of events, right? So that is really how your write model is going to look like. It's going to be a bunch of representations of entities that are stored in terms of every single event that happened to them, right? And now you can see how things work, right? So if you want at any given point in time, all of the things that happened, you look at your write model. And you can maintain your write model. You can issue commands to your write model, because at the end of the day, all you're doing is requesting a change in state, right? So you're requesting that an event occur to that particular bit of data, and you can store that away very, very quickly, right? And you can still implement your write model in a meaningful fashion. Whereas when you're actually going to do a write, right, all you really need to do is represent what state you want at that moment in time, right? So typically it's going to be the current state, but not always, right? As we'll see in a moment. So again, the commands are going to be issued to your write model. The write model is going to store those events in an event store. It's going to emit the events that actually happened. And those events are going to be propagated to the read model that is going to maintain a view, okay, a current state of the application. Queries are going to be issued against the read model, and commands are going to be issued against the write model from the UI. Okay, so why would you want to do this thing, right? So that is a completely fair question, and you really need to, in order to apply any of this stuff, you really need to understand the whys behind it and what is the use case for this. So a big benefit of this event sourcing model is really that it provides a natural audit trail. Right, so it's an automatic ledger. You don't. It's a ledger that is built into your data model to begin with. So in cases where you need that, right, you need that additional transparency, you need that additional accountability. You have a ledger-based system, let's say. At any given point in time, you need to figure out what happened or why something happened. That is a very good use case for things like event sourcing. So it provides a natural audit trail. You don't have to have an additional audit mechanism. The auditing mechanism is built into the data model to begin with. Now, as we mentioned, in traditional ways of storing data, it's very easy to get current state. It's very difficult to understand what was the state at a given point in time in the past, right? But that is very easy to do in terms of event sourcing because all you're doing is storing events. So you can take a look at a given point in time, what was the state of the system at that point in time, very, very easily by simply replaying those records, the events up to that point in time. So it's very, very handy to write temporal reports, especially ad hoc temporal reports, which is the next point, right? So when you don't know how your reports are going to look like, when you don't know how your ultimate UI visualization is going to look like, or it's something that is changing very, very rapidly, CQRS gives you quite a bit of design flexibility, right? Because you can keep your domain model sort of in a canonical way, and basically throw away your read model and change it at will, right? You can hit delete on an entire read model without any data loss whatsoever. You can simply recreate that entire table, based on all of the history that exists and get to that exact bit of data that you need. So it gives you quite a bit of design flexibility. It also gives you a little bit of design flexibility in terms of microservices. We'll talk about that in a second as well and see why that is the case, right? More so than the traditional ways of storing data. Okay. Another very, very useful characteristic of event sourcing is that it is super efficient writes, right? And in fact, super efficient reads as well, right? So the read model is efficient because you're optimizing it. The write model is efficient because there is no locking involved whatsoever. It's very, very low overhead. All you're doing is always doing inserts. You're always doing additive operations. So in cases where, again, it's a very, very high performance is necessary, especially in terms of reads and writes, and you need scalability, this is a good way of achieving it because you're eliminating basically locking altogether whenever you're doing any kind of changes to a system, because everything is an insert, everything is an add. You never delete anything and you never modify anything. So there's no real reason for having a lock in the first place. Okay. So let's talk about why Axon. Believe me, I say this from, I look at this from a realistic perspective because I've done CQRS and event sourcing without Axon and I've done it with Axon. And it's a world of difference, right? So as I mentioned, you can do all this stuff by yourself. A very naive approach is trying to do this through database triggers and handwrite basically your entire CQRS mechanism. Write an abstraction that maintains your write model through event sourcing and using relational database tables. Write your own eventing mechanism. Write your own event observers and distributors. Write your own query processing engines, and you can do all that stuff. At the end of the day, you will quickly be dealing with a bunch of stuff that you weren't foreseeing, namely reliability, concurrency, database storage, and really writing a bunch of infrastructure code that you don't need to deal with. You'll quickly stop working with business logic, and you'll very quickly become a framework developer. For Java developers, this is really not unnecessary, right? Because you have a framework that does all of this for you and does it in a very, very good way, and it's a very, very mature framework, right? Axon's been around for more than 10 years, and it's definitely used in production. It has got a ton of features in it, and it will basically stop you from writing all this infrastructure stuff and stop writing all the boilerplate and really stay at the business logic level, because all of the low-level details of CQRS and event sourcing is basically taken care of by the framework itself, as opposed to you having to deal with it. You'll see that when I show the actual code example and demo. Okay, so talked about this already. Basically, you don't have to debug infrastructure code and deal with a bunch of crazy infrastructure stuff, and it's already a proven solution, so you don't have to do this stuff yourself, and it's open source. You don't actually have to pay anyone to do any of this stuff. The other interesting thing about Axon is that it also basically forces you to use these design patterns correctly, right? So when you're using the framework is very opinionated, right? It has an opinion about how you should be writing your domain model, how you should be doing handling of events. It basically forces you to do CQRS and event sourcing the right way, right? As opposed to you're having to basically redesign all of these APIs and semantics by yourself. Okay, so let's put it all together. So I do have a example on GitHub. It's on my personal GitHub account. It's basically a super simple example, as simple as I could get it. The domain is gift cards. So again, this is a natural ledger function as well. So when you're maintaining a gift card system, you better be able to say, what happened at any given point in time, especially for given things like anti-theft or anti-fraud situations, or even just regulatory requirements. So this is a good domain for CQRS and event sourcing. So let's take a look at the code real quick. I'm going to run the code in Eclipse, but I'm actually going to show you the code in GitHub. I think it's a little bit easier that way, and it gets a little bit, I think, ugly in the IDE. So I'm going to just run this application. It's just a Maven application. It's happened to be using Spring Boot. Axon is not limited to just Spring Boot and Spring Framework. You can use it with Java EE or CDI if you wanted to. You can use it with the plain Java, and just Topojos if you happen to be using not Spring, but let's say Micronaut or Helidon or Quarkus. So nothing stopping you from doing it. There's nothing Spring Boot specific about it, but my example happens to be in Spring Boot. Okay, so I'll do a clean. All right, I'll do an install. I know you're going to tell me package, but I'm just lazy, and Eclipse gives me install, so I'm just going to do a Maven install. Okay, so there we have it. I'm gonna just run this via Spring Boot. So there is a Maven command to run Spring Boot. That's what I'm gonna use. I could use just Java direct jar if I wanted to, but I'm a little bit lazy, and this is the easy way. So
hey, Reza, we just got a question from Dan. How is the growth of the event log managed? It seems like it would get pretty big.
Okay, so let this start up a second, and let me make sure it starts up properly, and then I'll answer the question.
Sure.
All right. Yes, absolutely. It is absolutely true, and this is one of the things that Axon actually handles for you, and one of the things that you will need to deal with if you happen to do this by yourself. So basically, the way this is controlled is something called snapshotting. So in snapshotting, what you do is you take a certain, you have your entire event log, right? So it's let's say you've been doing this for 10 years, and you have a huge event log. What you can do is you can take a snapshot of that particular entity at a given point in time. Let's say 7 years ago, because that's all you care about. In your application, realistically, you just care about 7 years in the past, and everything before that you don't care about that. Right? So what you can do is you can create a snapshot of the data, like say 7 years ago, and basically truncate the data that's older than that, and then build your event model after that point in time, right? Or any given point in time, right? If you don't need the data beyond 3 months, well, just store the 3 months on snapshot list. In Axon, this is super simple. You basically, it's all handled for you. You can say, I want a snapshot with this particular point in time, and give me an archive of the rest of the data. I'll store it in secondary storage somewhere. You can also do the reverse. You can take an archive and reconstitute your snapshot if you want, but you can also snapshot and move forward. So that is one way of managing the size of your event source, and that is a very common problem. If you do CQRS for a little while, you will run into that issue. Okay, so let me show the application real quick. It's nothing fancy. It's just designed to just show you the code, actually, more or less, and show you some of the concepts. Okay, so I'll open up port 8080. So here it is. Let me issue a single card. Let's say ABC123 and issue it for $25. Let me do another one, DEF567. And let's say this one is $50. And as you can see, that's my visualization of my UI. Right? So this is listing all of the cards here and when it was issued at and what the remaining value was. Let's say I'm at a store and I redeem this card. So I redeem ABC123 for $10. Okay, and I hit submit. And obviously the value went down from 25 to 15, right? So I used up $10. So that is basically a very simple application. The basics of what you can see. Obviously, you can implement this without CQRS. But in this case, we are using CQRS for this because, as I said, this is financial information. This is a natural ledger situation where, yes, probably at the most applications, they don't care about all of the transactions that happened in a gift card. Almost no one wants to see that, right? So, but the retailer wants to see, okay, what is the remaining value on this card? And as a customer, you may also want to know that, right? So when you're using a gift card, you'll say, okay, how much is left on this gift card? But at the same token, for regulatory reasons, for anti-fraud reasons, you would want some record of what is happening with these gift cards. So let me show you that database, what is going on in the database. In this case, Axon. So Axon can store events in multiple different ways, in NoSQL, in relational databases, in Axon's own optimized storage mechanism. So there's multiple ways of storing this data. In this case, I'm using the simplest. The simplest default is basically an in-memory database. So this is just an H2 database that I can log on onto. I'm going to just cheat a little bit here and get the connection information from my GitHub page instructions. So basically everything that I'm doing here, you can do yourself. Oh, it was already there, actually. Okay, so let me test the connection, test successful. Let me connect to this database. So let me show you let me show you all of the information here. So here's the card summary. So if I run this dude, okay, you can see basically this is remember I talked about table per UI screen. This is basically your summary data that you can see right here. So issued at, initial value, and remaining value. So you can see the information. So that is basically our only visualization here, right? There's no other visualization per se other than that. But I will show you the way the data is stored in the domain model, right? So let's take a look at that. So these are all of the events. Okay, so domain event entry is where this is stored. So this is actually recording every single event that was seen by Axon. Right? So this is the issued event, another issued event, and there's a redeem event. So there's 3 separate events that were issued here. So you can see the rest of the information here. There's really nothing much else here other than the event itself, right? And the card summary and sagas. These are all internal things for Axonic. But the main data is really stored in this event table, and thus this is from where we'll be visualizing our entities, as we'll see in a moment. Okay, so let me close this. close that and begin to show you the code, which again, I think it's easiest to show in GitHub actually. So let's dig into here. Main gift card, and gift card application is pretty simple. It's just really just bootstrapping Spring Boot. Let me increase the font size. Okay, can you see the font size, Paul? Is that an okay font size?
It works for me, mate.
Okay, fine. Let me give it one more. Yeah. Okay. So nothing exciting here. It's just the basically the Spring Bootstrap stuff. But if you look at my package structure here, I've deliberately kept it relatively clean, and this is actually how Axon wants you to package things as well. When you look at the Axon examples, it's all follows the same pattern, and almost every single application is basically starts this way. Right? So there's the command model. Okay, this is where basically your write model in the CQRS portion. There's a UI, so whatever the UI visualization code that I have. There's a query model, right? So this is where I'm doing the read model, and there's some infrastructure pieces, right? So in the infrastructure pieces, I don't actually have a lot of things. The only thing that is part of my infrastructure is the Axon configuration. I'll actually show you that last, right? So just so we're not getting distracted by unnecessary details. I will show you that in a moment. But let's start with the
question, Reza.
Yeah.
How do you manage changes to the data model? For example, you add a new attribute to existing data with a default value.
So that's a good question. So what happens when you change the fundamental model for the entity, it's actually all right? So as long as you're adding things. So in other words, you're just it's a you're making backward compatible changes. Everything is okay, because what happens is all of the events that you had issued before, those were in terms of that model of the data that you had in the past. Okay, so as long as you're doing things like adding fields or adding a new entity, life is good, because you can still replay your data model from the very beginning and you'll be fine. Where if you make a change to your model, to your entity, let's say you renamed a field, right, or change your data type in a fundamental way, then you will need to do something. So in Axon, there is this concept of translators or adapters. So basically, what you do is you attach this. If you change so let's say you renamed a field, you also need to tell Axon that, hey, I changed this, and here's the code. Here's the thing that you need to do in order for this past event to make sense in the present. So, for example, a field was named X. Now I named it Y. Well, you need to have a translator attached to your model that says, hey, please change X to Y. Right? When you apply when you realize this model, please apply that change. That's one way of doing it. The other way of doing it is snapshotting again, right? So you can snapshot the data at a certain point in time, manipulate the data to be whatever you need it to be, and then move forward. Right? So that's another way of handling changes to your domain model. So yes, in terms of the read model, change away, right? It doesn't matter what changes you make, but in terms of the write model, you have to be careful in a CQRS model. But again, Axon does that for you. That's one of the common problems that people run into, and hence there's a solution to that in Axon. So let's take a look at the command model. So in my command model, I have gift card, which is my domain, which is my principal entity, and in fact, it's called an aggregate in terms of DDD. And again, Axon basically follows the DDD patterns. So this is an aggregate or an entity. You can think of it as a sort of important entity in your system. This is what Axon will maintain for you. Okay, so it looks more or less like JPA. So there's an ID, and then there's a state called remaining value. But you'll notice there's no getters or setters, right? So there's nothing getting or setting anything whatsoever. What there is instead is in this write model, there are commands and events instead. Right? So there's an issue command. So this means that you are going to issue the card. So this has a identifier that relates it to the aggregate, namely ID. So you're issuing a card, and you're issuing the card for a certain amount. Okay, so similarly, you have a redeem command. So those are the only two things. You can think of it as buttons in your system, right? For each button, you'll have a command. You also have a redeem command, and that this matches our UI. And again, it's going to be the ID. Okay, what card ID am I changing it for, and what amount am I redeeming? Right, so that will be your commands. The command now, if you look back in your write model now, what you'll see is there is no getters or setters, but there's basically command handlers. Right? So basically, your entity has state, and it knows how to handle commands. Right? So when you do an issue command, it's going to do some validation to say, hey, can I issue? Is this a valid card issue? And the only business logic here is that, okay, the amount needs to be greater than 0, right? And if it is, then I'm going to issue an event, meaning that, yes, this is successful. We've successfully created this thing, and I'm handling this command, and as a result, I'm going to issue an event. And the event is really what's going to be stored at the end. Right? So I'm going to say apply new issue event, and I'm going to say, okay, this is I'm applying the ID, and these things can be different. The command and the event can actually look different. Right? The event pertains more to what happened as a result of you issuing a command. Right? So you could be generating fields, for example, inside of your command handlers. Okay. So similarly, when you redeem, we're actually not going to do anything at all other than simply make sure that this is a valid redemption. And if it is a valid redemption, we are going to issue an event. And this is the event that is going to be stored, right? So forevermore in your event store, that's the actual thing that's getting stored, right? It's not the current state that is being stored at all. We do have a current state here, but the only reason we're maintaining current state is actually because we need this remaining value to be valid for our business logic, right? So it's not that I care about this value from a read perspective. I care about this value, and the only reason I'm maintaining this value is only because I need it for business logic purposes, right? That's all. Right? Other than that, I actually don't need to store anything other than simply storing the events. So there is also, so the question is, well, how do you change that value then? Right? So you change that value with something called event sourcing handler. And not every single event needs an event sourcing handler, in fact, right? So in some cases, you just want to record an event and not worry about it at all, right? But in this case, we do, right? In this case, when we are issuing, when we have an issue event, we want to make sure that we get the ID and we update the remaining value. And similarly, when we do a redemption event, we are updating the value, right? We're decrementing the remaining value with the amount that was redeemed. Okay, and that is about it in terms of the read model. So it gives you an idea of how this looks like. So again, there is no crazy queries here, nothing crazy you're doing whatsoever. It's just there's your entity, you're modeling the entity, you're modeling handling commands, and you're modeling emitting events. That's all. That's all you're doing. So let's take a look at our query model now. Right. So if you look at the query model, this is the card summary. Okay, so your card summary is nothing much more than a JPA entity. Okay, so it has values like the ID, the initial value, the when it was issued, the remaining value, and that's it. It's basically a representation. It's a record representation of what's in the card summary UI. Right, so it's a one-to-one mapping between the UI. So there's something that is taking those events and updating them, right? And that thing is called card summary projection. Okay, so what you see here is that this projection, what its purpose in life is that it takes the things that are coming in from the event bus, right, from all of the events that are happening in the system, and subscribing to the events that interests it. Right. So in this case, we are actually interested in both the issue event as well as the redeem event. Right. So these events, when we receive these events, basically what we're doing is when we get an issue event, we create a new card summary, populate it, and save it into the database. So we're doing an entity manager .persist operation, as you can see here. But we're also publishing the event, another event which you can do. It's called card summaries updated event. And the reason we're emitting this event is actually to notify the UI that, hey, something happened that is relevant to you. Go update go update your state, right? In fact, you'll notice it can be a very limited thing that we're updating, only just that ID, right? So we're saying to the UI, go update yourself. So same thing here, right? When we get a redeem message, we're retrieving the relevant card summary, updating the card summary with the remaining value, right? And then simply issuing another event that says, hey, we have an update, UI update. UI, please go update yourself. There's also something called a query handler, which you don't actually need, right? But it's a nice abstraction as well, right? So this is in terms of Axon, you have the option of even modeling your queries as objects by themselves, right? So in this case, we're getting a query. There's a query handler interface, and in this query handler interface, we're just issuing select star, more or less, right? It's nothing much more than that. We're doing pagination and whatnot, but really, we're just getting getting a select star. The query is very, very simple. Right? If you look at card summaries, it's just select star from that table. That's all. Right? So it's a very, very fast thing for the database to execute. Right? So this is this is another query handler, card summaries query. Right? So this is basically telling us, hey, how many. What is the summary of all the cards that you have? Right? Card summaries, count card summaries. All right. So that is the read model. I think that is all that I really want to show you. The rest of the code, I think you can take a look at yourself. It's relatively self-explanatory. I'm also running out of time. I do want to talk about some important stuff other than this. I'll finish by showing you the Axon configuration. So I'll also show you the test. Right, so you can actually write tests in terms of CQRS. Right, so Axon will allow you to do that. Again, feel free to take a look at this yourself. But basically, you can do things like simulate the actual events. Okay, so for example, test issue card is given no prior activity, issue a command with this thing, expect successful execution, and then expect one event to be emitted. Right, so that's how a test looks like. Okay, so going back to Axon config before we go back to the presentation. So here we have infrastructure and Axon configuration. And it's super simple, right? Because I'm taking the simplest possible thing. So I'm saying that I want the event bus to be the storage event engine, the default one. Okay. I'm saying that I want a query bus, but this is going to be the simple query bus, so in memory, right? So this is I'm using this particular query bus to update the UI to update itself. Right? If you notice when I did something, it updated the bottom part of the screen updated itself. This is because of this. So it's an in-memory one. The primary event bus is event storage engine. So this is basically using the default database that's configured for this application. I'll show you that in the Spring Boot configuration itself. Right, so that is basically using the database, and as you can see, as you maybe have noticed when I showed you the database, the actual events is serialized as JSON. That's because I have a JSON serializer. But this can be infinitely complex. Right? There's many different configurations in Axon where you can use different storage mechanisms, apply those translator objects, actually store different parts of your system in different machines, so it can be a distributed system. This can be very, very complex, but in this case, I'm showing you the very simplest thing. I'll show you the.
We have a quick question, Reza.
Sure.
Question from Eric. Oh, everything just went blank. Hang on a second. Let me just go back to it. This seems like this architecture would be good for state unemployment claim websites. Accept claims without crashing, process them asynchronously as you can. Recover from crashes by replaying events.
Yes, you could. That certainly could make sense, right? I mean, that seems like a. I don't know the domain. I can't pretend to know, what the domain actually entails, but it sounds like a ledger system, right? So it sounds right, more or less. Yeah, but I couldn't tell you, before I actually understood the domain. But yeah, it could be a good fit.
Cool.
Okay, so there's a Spring Boot configuration. It's straightforward. Again, this is how Axon is detecting that. Yeah, I have a database here, and I need to store my data in the database. It's auto detecting all of those configurations from Spring Boot, and it'll do the same thing for Java EE too. Okay, so closing the code example, let's go back to our slide deck and talk about a few important issues. I do want to stay more or less in the hour time frame. Okay, so there is a tie-in for things like CQRS, and event sourcing, right? And microservices in particular. So this sort of stuff, it's actually not necessarily has to do with microservices. You can, people have been using CQRS and event sourcing for eons with monolithic systems, but there is a microservices tie-in. So the most important tie-in is if you go back to this model that I showed you before, right? Notice that everything is communicating with each other through messages, right? So commands are messages, queries are messages. These are objects themselves. And events are messages as well. And as you dig into the code, you'll notice that the UI never actually makes a direct invocation to the write model. It always simply issues a command or issues a query and receives a result from Axon. Similarly, you saw that the read and the write model do not directly reference each other either, right? So they communicate through events and commands. So what this means is the entire system is actually loosely coupled, right, based on messages, events, and queries. So you could, in theory, right, break this up into infinitely small pieces, right? You could have the UI in one machine. You could have the right parts of the write model in several machines. You could have parts of the read model in several machines, right? So this is something that actually naturally falls out of the event sourcing model. It makes it, because everything is loosely coupled and message-based to begin with, is very easy to break apart if you wanted to do that. So actually CQR, if you follow this pattern, it allows for what's called evolutionary microservices development, meaning that you can start with a mostly a monolithic application, and then it has the ability to allow you to break things up without changing very much of your application, but simply actually changing Axon configuration for the most part. Right? So you can simply tell Axon, hey, for this particular type of command, this command should be routed to this set of machines. For this event should be routed to this set of machines, right? As opposed to doing that yourself. So another tie-in with microservices is something called Saga, right? So you saw a Saga table, perhaps, when I showed you the tables. So in CQRS, there's this concept of a saga. And what is a saga? A saga is simply a long-running action of some kind, right? So basically, it's a set of interrelated events and commands, right? So you in order for something to complete, you have to guarantee that a certain set of events and commands have transpired, and the system is in a certain state. One good example is reservation systems, right? So you can say, in the command model, you can say, okay, issue a command for reservation. The system will simply tell you, received, right? I've received your reservation, but not actually tell you if that actual reservation was actually made. So that reservation can go through multiple such events and commands to say, verify your credit card. Is there still availability, and various other things before everything is considered done to a state where you can actually say, yes, the system is actually reserved. Or you can also say, no, I was not able to actually successfully process this reservation, and the reservation is canceled, right? So in order to save a process, a model long-running process across multiple aggregates and multiple views, you actually create another abstraction called a saga. So, and that is actually persisted in the database. So you can take a look at any given point in time. What is the current state of the saga? Is it completed or not? Right. So this is comes in very handy in distributed. This is basically nothing much more than modeling transactions inside of objects in your own application using CQRS and events and queries. Right. So this comes in handy if you're going to do transactions, but you don't have the ability to enforce ACID, let's say because you're dealing with a distributed system of microservices, but you can still model ACID behavior, right, using the saga pattern in CQRS. So this is another use case, interesting tie-in between CQRS and event sourcing and microservices. And also an offshoot of this is something that I call CQS. Okay, and that is basically when you have microservices and you have an event store, and that particular event store is stored in one database, one table in a certain machine, but you have parts of that data in other databases, so in a denormalized fashion. So let's say you are storing your a person's employment history. Well, nobody needs to know the entire employment history. Perhaps another system may only want to know what is the current working address of this person, right? How do you synchronize between these systems? This is another place where CQRS and event sourcing comes in handy, because what you can do is you can model the main state as events, and you can emit events and transmit them wherever you want it, and only update the read model in a separate system wherever you need it. Right? So that is another use case for CQRS. In this case, the events are serving the purpose of system integration. So I call these integration events. Right? So this is another tie-in where you have a use case for this, and where it comes in very handy for microservices. So in this case, it's solving distributed data synchronization as a problem. Okay, so do use this wisely. CQRS and event sourcing is not for the faint of heart. As you can see, the way things are modeled, even for a simple domain, is very different than what you would in terms of using your normal domain-driven design and relational databases, right? And you almost have to think about programming in a whole different way, right? So there is definitely value to this, but there's also complexities to this also, right? You can't just frivolously do this for fun, right? You have to make sure that there's a good use case for it, because you will ultimately pay a tax for the complexity, right? It'll be difficult to understand the system, especially for a newcomer that is not familiar with the CQRS and event sourcing model. The other thing to understand is don't overuse this, right? So I'll tell you, in every single situation where I have seen CQRS and event sourcing in play, it's a subsystem. There's a particular problem that's being solved by CQRS and event sourcing. It's a design pattern for a particular problem to solve. But the rest of the architecture need not all be CQRS and event sourcing. CQRS and event sourcing lives perfectly well with other ways of modeling data. So all of your other data could be just simple RDMS stuff, and you could have just a particular bit of information that uses CQRS and event sourcing. And the way you do the tie-in is through events, and basically you pop back up into the normalized relational world through your materialized views. Right? So your views live in the normalized world, whereas your event sourcing bit can live in a different world in Axon. There are some domains where CQRS and event sourcing definitely fit very well. Right. So one place where CQRS in particular fits very well on its own right is e-commerce. So you need a lot of performance is definitely, and read performance in particular is a very big concern. All of the read models are typically in a read model and the separate write model. Typically government, where there's a lot of regulation in place, a lot of auditory needs. That's a place where CQRS and event sourcing is often employed. Finance, accounting, healthcare, these are all cases where you need to have a lot of transparency in terms of what happened in the past, what happened in a given point in time. Gaming, this is typically for, what I mean by gaming is really gambling. And again, this is another domain where there's very strict regulatory requirements of modeling and having traceability of every single change that happened in your system. Logistics, talked about reservation systems already. Often airline reservation systems or some reservation systems, some other kind of train reservation system, they will employ CQRS. They'll principally do that because of this distributed synchronization problem using the saga pattern. That would be the typical reason for reservation systems to use this sort of architecture, because ACID simply doesn't work. Often, in order to do a reservation, you'll need to talk to external systems that is just not subject to ACID transactions to begin with. And we talked about the particular use cases for microservices as well. Right? So where you want to do, let's say, event-based microservices, or you want to solve a particular problem of data synchronization across microservices, all of those cases are valid as well. And of course, the saga pattern. But again, just like CQRS, microservices should not be taken lightly either. Right? There is a complexity and maintenance tax to be paid there as well. So you need to think about those cases before you really dive into these things. So yeah, CQRS event sourcing, useful patterns. Definitely, I've used them myself. I've used Axon to do it, and I've done it without Axon, which is a regrettable decision on my part, I think. And I think back when I was doing it in the very beginning, there wasn't even Axon around. You kind of had to do it by yourself. So it does make it a lot easier to implement CQRS and event sourcing in Java. Okay, so we have a very handy tool to do this if you happen to be a Java developer, much more so than any other technology. There is relevance to microservices as well, and I'll leave you with some resources. So I think Martin Fowler has some very good explanations of CQRS and event sourcing. It's a little bit abstract. I'd like to think I've done a less abstract and more concrete, sort of grounded explanation of these things. But I think, if you've attended this talk, you'll be well equipped to now go take a look at the Martin Fowler write-ups, and hopefully it makes more sense. And of course, in order to look at anything Axon, you visit axonic.io. The good folks there at Axon will be happy to hear from you. All right, so that's it in terms of my presentation today. If there's any other questions, I'll take them. Otherwise, I appreciate everyone's time, and I hope this was
There are definitely some questions.
Okay.
There's quite there's a discussion going on in the commentary about performance issues and having multiple instance issues with Axon, but save those, they didn't get raised as proper questions. So the first question we have here is, how do you manage storage with event sourcing?
That's a bit of a vague question. Okay, I'll try to answer it. So you can manage storage however you want it. So you can store it in relational databases. As you can see, it's just a table that stores all of the events. That is a way of doing it, and it's a fine way of doing it. If you have a moderately sized database, moderately sized data set, and you're very religious about like pruning your tables and doing snapshotting over a period of time, it's not so good if you really have very high performance needs and you have a lot of data, and you're modeling a lot of things using CQRS. In that case, there is something called Axon Server. You can definitely take a look at that product. It's not open source; it is commercial. So that is generally a way of doing CQRS as well. You can try to store your events in other ways. A lot of people, when I was at Axonic, were asking about Kafka, for example. Usually it's not that easy. It sounds compelling on the surface, but the issue with CQRS is in the event write model, you need to have a concept of ordering. So that is a very, very important concept. And Also, you need something that can handle transactions. More specifically, handle concurrency well. So things like NoSQL and Kafka, those don't tend to be very good fits. Usually you're better off with a relational database or using Axon Server. Obviously, the read model you can store honestly wherever you want. Whatever is the best fit, I would say, for moderately complex needs and moderate efficiency needs. It's again, a relational database is fine, right? Especially since your queries are very simple. You can basically get away with a relational database. It tends to be overkill because you're not using half of what relational databases are about, which is writing these crazy complex queries and being able to execute them in an efficient way. So maybe another answer is you don't use a relational database. You use something that doesn't have those complex query capabilities like NoSQL.
Okay, thanks. Good answering, I think, there. Thanks for that question, Michael. Okay, the next question I have is from Anthony Bird. Is CQRS a form of reactive programming? Is AKKA a competitor to Axon?
Not really. So there's some reactive. I think you can say that Axon is reactive compatible, right? So in other words, there's nothing. It happens to be a non-blocking, asynchronous, scalable. All of those the little R's in reactive. It's compliant to all of that. Would you use CQRS just to become reactive? I don't think so, right? Because there's a lot of complexities and side effects that happen when you're adopting CQRS. I think if your objective is you want to be more reactive, your answer shouldn't automatically be let's use CQRS. I think your answer to using CQRS and event sourcing is I have a use case for CQRS and event sourcing. But I do think CQRS and event sourcing is probably, at least the event sourcing portion, is probably pretty reactive. But if you're hand coding, your CQRS model with triggers, which in theory there's nothing wrong with that. That's not a reactive model by any means, right? That's very old-fashioned using triggers to populate a view report, right? It's no more complex than that. I think reactive programming is a separate domain altogether. It's all about no part of your system or as many parts of your system need to be non-blocking and asynchronous and scalable and etc. It's an entirely different programming model on its own right. You can probably use things like Akka and like Spring Reactor and CQRS and Axon together. I must say I envy your tolerance for complexity if that happens to be your use case.
Thanks, Reza. Okay, next question we have here is another one from Michael. What alternatives exist to Axon in Java? Why not develop the patterns on your own? And what challenges do you see?
Definitely don't develop this on your own. You'll quickly find an answer to this yourself, honestly, by taking a look at the Axon documentation, and just above and beyond the code that I showed you, right? So, literally, when you look at this code that I showed you, the code is what you saw, right? There's no infrastructure code whatsoever. It's just purely business logic, and there's a lot of other complexities going on behind the scenes of routing events, storing events, materializing the views, query handling, all of those abstractions that is sort of behind the scenes in the Axon framework. All of that suddenly comes to the surface, and you got to implement all that. So you're literally doubling your work. You're not only writing the CQRS and event sourcing infrastructure portion, but you're also writing your business logic. And often there's many, as I said, there's like if you begin to look at Axon Framework, you'll see all of the nuances that you need to handle, right? So ordering the events, how do you manage synchronization in event handling and command handling? That aggregate object, for example, is thread safe. Axon makes that thread safe and make sure there's a sense of ordering and storing calling the event handler method after you store the thing in the database and ordering the events themselves and emitting the events, especially across distributed systems. So there's a lot of, and we also talk about snapshotting and data model changes, etc. All of those things are just, and that's just the tip of the iceberg. There's many other nuances that CQRS and event sourcing has that just is baked into the framework. And the majority of those things you won't even run across until it's too late, right? So you'll think, oh, I'm gonna implement this thing myself, and then, oh, I didn't think of this problem. Now I gotta rewrite my homebrewed framework to try and take advantage of that. Now, in terms of competitors to Axon, there isn't a whole lot. It's kind of a niche domain, and Axon, at the end of the day, is not really a commercial product. It's just a framework. I think, given how obscure this particular thing is, we're lucky that we even have a framework. I think there is a couple out there. I don't think they're as well used as Axon, or not nearly as old and not nearly as well deployed. I think Chris Richardson has like some kind of homebrewed framework for CQRS and event sourcing. I really don't think it's anywhere near as robust as Axon. I honestly don't know why you wouldn't use Axon if this is a problem when you had and you're a Java developer.
Okay, excellent. Thank you very much. I think we're done answering that one. There are currently no other questions on here, so I'm going to invite Jeannie back in so that she can help us with the raffle. Hi, Jeannie.
Hello. I shuffled the raffle. I shuffled the spreadsheet, and the winners of the license this month are Sandeep Chavan and Evan Friedenberg.
Excellent.
So if you could please put your email addresses. I'll send my email address and you can contact me.
Okay, that's probably the better way of doing it, yeah.
Yeah, sorry.
That's all right. So Jeannie will put her email address there, and then those two people can email her directly. Excellent. Yeah. Is there any other things we need to take care of? I think we covered everything earlier. All it remains to say is, let me pop this one up here. I'd like to thank Reza for doing the presentation. That was very good, very deep, and good amount of technical hands-on, which we like to see in these things. Thanks again to our host sponsors, Jakarta EE Open Source Cloud Native Java. We appreciate their support. Thank you very much, everyone. We'll close it down there.
Awesome.
All right, so I'll post the slides, on the meetup. I don't know how many people are in the meetup, but please look at the meetup site, and I'll post the slides there.
Great. It will also have the link to this Crowdcast event as well. So, great.
Cool.
Thank you very much, everybody. I've got to find the end button. Farewell.